it's a Wireshark. If you learn Wireshark before, then maybe this part you can quickly go through it. Right now, if you're listening to the class right now, you should download Wireshark and install it on your computer so that when I operate Wireshark on my computer, you can operate on your computer's Wireshark as well. So you don't need just listening to my talk. You can operate at the same time. This is acknowledgement. I reused some slides from other people's. So Wireshark is master known knowledge for network security because it is used by both normal people, researchers, and also by security IT staff because it's quite mature and powerful, and it's totally free. Essential for network management. For any management for routers, firewall policies, you need to use Wireshark to monitor traffic to see whether your policy definition is correct or wrong. Detect abnormal error in networkings. You can detect some errors or abnormal packet appeared in the network. And security management and traffic log for forensic analysis. So you can use Wireshark to log the data. So Wireshark was originally developed based on this TCP dump. TCP dump was developed when Unix is mainly used when the internet was first developed. At that time, only Unix machine used the internet. So people developed a TCP dump program, try to understand how the network works and discover and diagnose the network problem. So Wireshark, the basic, the core part for Wireshark is called T-Shark. So this is underlying core component for Wireshark. It is doing all the hard work, capturing the data, save the captured packet, and analyze those captured packet. Wireshark is basically add this graphic user interface to display this captured packet. In addition, Wireshark, beside this added graphic user interface, it also added many analysis modules. So you can run analysis directly on the Wireshark. You don't need to use another tools to process the captured packets. So this is TCP dump data. TCP dump data is like each line is one packet, and each line will have the timestamp of the Unix machine's CPU time, and this is IP packet because in the early stage, internet is just one of the network protocol. But as time goes on, internet becomes only one network protocol. All the other networking protocol has been died off because of the competition. So in the TCP dump, it has a field to see whether this is a IP packet or some other networking protocols packet. Then this is a source host name or IP address. If a source IP address has a domain name, it will show the domain name. This is the last dot showed the port. If the port number is a predefined reserved port, then it will show the name. Like this is port 22. It is reserved for SSH service. So the display, it will display .ssh. Then this is a destination IP address. It has a domain name. Destination port. This is not a reserved port, so it's just a display this port number directly. Then this is TCP packet header information. If this is not TCP packet but a UDP packet, then this will show the UDP packet header information. So you can see that this is a sequence number. This is acknowledge number. Remember TCP packet, the packet header, the main information is the port number, source port, destination port. Another information is the sequence number, acknowledge number. And another information is this flag, control flag, and congestion window size. So those are the packet headers information. So different output format for different packet type. T-Shark used in Wireshark, it captured data in a similar way as TCP dump. You can see the timestamp, source IP address, destination IP address, and port number. Well, it say the TCP source port is this, destination port is this, and this is ACK packet. Basically, the ACK bit is set as 1. So this is ACK. Sequence number, acknowledge number, congestion window size. So this is the TCP headers information. Basic use of TCP dump. If you run TCP dump directly on Unix machine, it will capture all the packet. You can try it on your own setup Linux, because in order to run TCP dump, you need to have root privilege, because TCP dump will use a lot of computer resource. It need to capture all the packet, so it use a lot of computer resource. So only root account has a privilege to run TCP dump. You can specify only capture which interface. If your computer has multiple interface, like if you run it on your router has multiple interface, then you can specify which interface packet I will try to capture. So you can capture certain packet like TCP dump, UDP, then you only capture UDP packet. And TCP dump, UDP destination port 53, then only capture DNS request packet. So as I mentioned when I introduced networking, this port number is very useful for you to determine what's the direction of the packet, because the majority computer on the internet, they are running in the client server mode. This client connect to the server, and this connection will go on. So destination port 53 means the destination computer is the DNS server. If the source port is 53, that means the source IP address is the server. So you use this port number in whether it is in the source or in the destination to determine whether it is coming from the server or coming to the server. So you use that to determine that. This TCP dump UDP port 53, this shows that we capture both either source port 53 or destination port 53. So this will capture both direction of the DNS request, DNS traffic. This one only capture DNS traffic sent from the DNS server to client. We don't capture traffic from the client to the server. This one capture only the traffic going to the server. We don't capture traffic sent by those servers. So this is how you use the port number to determine the traffic direction. Destination host, like a destination IP address is this one, or domain name is this one. So you can use a complicated way to determine what traffic you want to capture. We cannot demonstrate, well, you can demonstrate it in your virtual machine, in your own Linux, if you have installed a Linux virtual machine on your computer. Actually, there is open source TCP dump for Windows machine. It's called WinDump. So you can download it and run it on your Windows machine as well. It's very similar. It's similar syntax as the TCP dump. So Wireshark originally is called Ethereal. So that's the first original name for this project. Later on, it changed the name to become Wireshark. It's an open source tools, so it's totally free. And you can think that it has two components. One is the T-Shock, which is a packet capturing engine underlying this program. Another is this graph user interface. So if you put them together, it's the entire Wireshark software. So Wireshark uses a 5-layer definition of the internet to display captured packet. So in this 5-layered definition, application, transport layer, network layer, data link layer, and physical link layer. So there are 5 layers for the internet architecture. And so Wireshark display each packet using that 5-layered structure. I can start to run Wireshark. You can Google search Wireshark and you can download it. So when you start to run it, it will show many interfaces. Like how many show up here is determined by your computer. Like your computer may have 2 interfaces, like Wi-Fi interface and Ethernet card interface. This one showed on my computer it has this interface. These interfaces because I installed the virtual machine software. So you can see this Wi-Fi interface, it is working. This is loopback. Remember, in your computer, you have many networking process. Those networking process, when they want to exchange information within each other, they actually also create a TCP IP packet, but the packet will never go out of your computer. They basically send to that destination IP address is a loopback address. Loopback address is 127.0.0.1, so that is loopback IP address. So there are many traffic going on in the loopback interface as well, because your computer has many processes, they talk to each other directly. So when we capture, by default, it will use this, but you can click which interface you want to capture. And you can use the capture filter. This filter just means what traffic you want to capture. If you don't input anything here, you just capture all the data. So I will just capture all the data. You can select what interface you want to capture. When you want to start capture, you can click this one to start the traffic capturing. And these are traffic captured. And there are many packets going on because I'm using the Zoom meeting. Zoom meeting is a real-time multimedia application. So it uses a lot of UDP packet to send the data. And I can say, I will connect to this website using HTTP, and I also connect to this website using HTTPS. Both will be connected, and I will connect to my own homepage. And some other operation I can use is doing a DNS query. Well, I'm using Mac computer. Mac computer is essentially it's a Linux computer. So in the Mac computer's terminal, you can run basically almost all the Linux command. In Linux command, when you do DNS query, you use dig command. So suppose I do dig command like www.ufl.edu. Then dig command is sending DNS query and send back. And I can use the trace route. I introduced trace route in the networking review. Trace route, suppose I do trace route to google.com. You can see this is the trace route until 10th. It doesn't respond anymore. Florida net. Okay, what else I can do? Okay, I can start SSH. Like SSH command, EUSTIS, ECS, UCF.edu. Oh, so inside the campus, you should use the useTest.cs. So the trace route is still not finished. I don't know why this. We should be very close to Google, nearby Google server, but this trace route is just going on forever. Why the verification is so slow? Okay, so this one you can see I logged in to the Eustace machine. I will exit Eustace machine. Okay, okay, I have got enough data, so I will stop. When you stop, you click this red button to stop the capturing, and then everything will be finished. And well, my computer resolution is too big, so it's very small to show up. In the bottom of your Wireshark, you can do this operation on your own computer. In the bottom of the Wireshark, it showed how many packet has been captured. It has 187,000. So 187,000 packet captured just in this very short time. It's mainly because my computer is running Zoom meeting. Zoom video is keep recording, so there are a lot of packet. On your computer, if you're not running any multimedia application, then you may not have so many packet. And so this is what we captured. And view. This is a layout, but you can change the layout to be 3 window, but either one is fine. So this is a layout for my. So basically, the first window show the packet, and this is the number of the number, and this is a time step. This is time step. This is number, and this is a source IP address. This is the destination IP address. This shows what's the protocol for the packet, whether it's UDP packet or TCP packet. This is packet length. This is information, summarized information for that packet. And this second window showed this internet 5-layer structure. So this is a physical layer. You can unclick to see details of the physical layer. You can see this is a data link layer. Even though I'm using Wi-Fi to capture the packet, Wireshark will treat all the packet as Ethernet format. So in data link layer, you always see Ethernet format here. Even though this is a Wi-Fi packet, in data link layer should be Wi-Fi. But if you unclick, you can see this data link layer has this MAC address, source MAC, destination MAC address, source MAC address. The most important thing for Wireshark to analyze is this IP layer, network layer, and this transport layer. User datagram protocol is the UDP, the transport layer. Then the application layer, the data part for application layer. So that's the 5-layer structure show up for each packet. The third window basically shows the raw data for that packet. So this is the raw data. This is ASCII character for the raw data. Because some raw data, they corresponding to ASCII character, then see this ASCII character volume, you can see, especially for unencrypted traffic, this ASCII value will reveal a lot of information. So this is this original, this 3-window structure, and detailed packet content, the raw data. This is a 5-layer structure. You can see each layer by opening it up. Most operation in Wireshark is this display filter section. Because the capture packet, you can see that in the last two minutes, I captured 180,000 packet. So it's impossible for you to go through them one by one. Then you need to use this display filter a lot to filter only show the packet you are interested. Then you can read them, manually analyze them one by one. In some computer, you can capture packet in this so-called promiscuous mode. Promiscuous mode just means that you can capture, for example, in the Wi-Fi, if your network interface card allow this mode, support this mode, then you can capture all the computing device in this same hotspot in the same Wi-Fi network. Like in your home, you can capture all the home Wi-Fi device traffic. But normally a computer like our desktop or our laptop, the included network interface card does not support promiscuous mode. Then it can only capture all the traffic going to your computer and coming out of your own computer. So it cannot capture traffic going to some other Wi-Fi device in the home in the same Wi-Fi network. So in order to monitor, to eavesdrop on the entire Wi-Fi network, you need to purchase a third-party network interface card. On Amazon, on many websites, you can find and buy such kind of network interface card. So it has a capture filter option. You can specify what packet you want to capture. This is a capture filter example. You can capture only packet that has source or destination IP address equal to this. You can capture only TCP traffic where either the source or destination port is HTTP, basically. Because this port just means it doesn't specify source port or destination port. So any port that is equal to port 80 and the TCP packet, this will be captured. You can specify the MAC address, which MAC address the packet will be captured by specify this. This is capture filter. But normally we don't use capture filter because capture filter will actually slow down this capturing speed. I will explain that a moment later. The captured buffer usage is basically means that when you capture data continuously, Wireshark can save the data into your disk, and you can specify how much disk storage you want to use for the Wireshark to save this captured packet. And the cache is basically how many internal memory will be used for the Wireshark. And when the specified disk storage has been used up, then newly captured data will overwrite the old captured data. So you will not overwhelm your hard drive. Like in the capture, you can specify capture file. You can specify how many files you want to use to save the captured data. You can specify each file is how many megabyte or gigabyte for each file. So what we mainly use and will introduce in detail is a display filter. Display filter is called post filter because it only used to process the capture traffic to show up whatever satisfies this filter. It doesn't change the captured trace. So no matter what kind of display filter you use, you do not change the capture. You do not change anything on the capture trace. Capture trace is still out there. Display filter is much more powerful than this capture filter. Display filter this is some example. It's IP dot source equal. So it just means if the source IP address is within the subnet, then the packet will be displayed. When this TCP port is equal to 80, this means all. This is AND. This is logical operator. This is AND. This is all. So when the TCP, either port is equal to 80 or either port is equal to 3389. 3389 is used by Windows remote desktop. So if you see a packet that has a port number 3389, then you know that someone is using remote desktop to connect to a Windows machine. This is not operator. So you can combine them to generate much more complicated display filter. This is the syntax for the display filter. The first is the protocol part. Then you can have a second substring, third substring for this to specify what value you want to investigate. So protocol part is like this IP, this TCP is the protocol part. Then this is the first substring. You can have a second substring as well. Then this operator, comparison operator, either equal, you can, or equal is present. So this is the operator. Bigger, smaller, contains. So the operator, there are many of here. So one operator I want to emphasize is this contains. Contains is very useful. I will demonstrate that in a moment. Basically, if you want to search for a specific ASCII string, then you can use contains to see whether any packet that contains that specific ASCII strings. So it's very powerful tool to search for a specific signature in a large amount of packets. This is comparison operator. The last operator is called logical operator, like XOR or some other operator here. So before we show how we can use display filter, first you need to have a pretty good idea of this TCP header and IP header, because the most operation on the display filter is about TCP header and IP header. So you need to understand this TCP header and IP header. TCP header, it has a source port, destination port, sequence number, acknowledge number. Then it's the control flag. So control flag is very important for set up firewall rules, filter rules. Receive window size. This is the congestion window size. Checksum and those. And in the display filter, you can say TCP dot source port equal to 80. So we will only show TCP packet that has source port equal to 80 to show up. You can have you can represent the same concept using two different way, like TCP dot flags equal to. That is equivalent to TCP dot flags dot thing equal to 1. This is the first substring, so flag field. This is the second substring, just to specify that thing bits in that flag field. And this thing bit in that flag field is equal to 1. Then, so it is equivalent to TCP. Well, this is not equivalent to TCP flag equal to 2, because TCP flag equal to 2 means the thing bit is set as 1. All the other bit is 0. If you use this display filter, it only specifies the thing bit is 1. So other bit may be 0, maybe 1. It doesn't care. So for example, for my capture trace, if I say TCP, well, it's so small. I don't know if I can make it bigger or not. Oh. Zoom in. Okay, so it will at least make this bigger, but this display filter is still very small. TCP dot like, so here Wireshark give you this very good way so that you don't need to memorize all those words anymore. It's just like a good compiler when you do programming. You can type just a single dot, then all the first substring will show up, like all the first substring will show up. So you can see flags. And flags, it also show what kind of second substring is possible for this flags. You can see this TCP flags dot thing equal to 1. Then you can see all these packets, their thing bit are 1. But the other bit could also have some bit set. And you can see the status bar to see that it displayed 653 packet. So there are overall 653 packet that have a thing bit equal to 1. But if I use this TCP flags equal to 2, the number of packet will be smaller, because TCP flag equal to 2 means only the thing bit is 1. All the other bit is 0. So if we use this, you can see that we only display 382 packets. So only thing packet show up. The SYNAC packet will not show up. If you type something wrong, this will not show. This will show as red. So that means you type something wrong in the display filter. If your syntax is correct, this display filter will show up as green. So that means you can use. So If it's still red, means that it's incomplete or has something wrong. If it's green, then you can use that display filter. So you can see that this one will have a SYNAC. So SYNAC packet will also show up. So this flag field, these several bits, they come together as the flag field. Syn is the second bit. So that's why if all the other bit is 0, only syn bit is 1, then this value will equal to 2. If you use the value flags equal to 18, that means that both the syn bit and ACK bit, they are set as 1. All the other bit is 0. So that will be this case. You can use this is logical operator or this represent all. You can use this select format, or you can use the English word for those operator, like equal. You don't need to use this equal. You can just use the EQ to represent that comparison operation. This is and. You can use English word and to do that. So if a filter syntax is correct, it will be highlighted in green. If filter has something wrong, it will show up as red. So then you cannot use that for the display. Okay, let me take a 10 minutes break. So right now it's 11:40. So let's resume the second half of the class at 11:50. Okay, we will take a 10 minutes break. Okay, let's start the second half of this class. First, after you use display filter to show the packet you want, then you can save those displayed packet in a separate trace file so that you don't need to, every time you operate on the original very large trace file anymore. Because the trace file could be gigabyte size or even more, which is hard to load and to process once. So after you process once and get the packet that you want to analyze, you can save them as a separate file to be smaller. Like right now, I capture this, I can save this file. You can see the size. Save as okay, so this is you can see the file size. So this trace file, the default file name is pcap pcap-ng. So that is file name. So it has 168 megabytes. So that's very large. But if you want to just analyze, because the majority packet here is UDP, is because of my Zoom meeting. So if I don't care about Zoom meeting, I want to remove those Zoom meetings packet. You can either just save TCP packet if you don't care, but DNS query is also based on based on UDP. So if you only save TCP packet, then those DNS query packet will also be kept out. Let's just try that. Suppose I'm only interested in TCP packet. So I just say TCP. Then here the packet is 83,000. Well, it's still a lot. Suppose I just care only interested in DNS packet, then I can use a UDP dot port equal to 53 to just show DNS traffic. So DNS traffic right now is only 298 packets, so that's much smaller, very easy to analyze. So if I want to save this, I can say file and export specific packet. You use this export specific packet, and you can see all packet that displayed 298 packet, and compression, you can compress them, but I want to save it as uncompressed. So this is, I say this DNS in class, DNS traffic. Then you can see that this trace file is only 72 kilobytes. So it's much, much smaller. So later on, you can just analyze this much, much smaller trace file for easier analyze. I will still open the original big size of data. So 187,000 packet. So this is original capture trace file. Okay, so this is that you save this filtered packet as the original trace format, so you can analyze it later, still using Wireshark. But if you only want to save some displayed information, like UDP, suppose UDP dot port equal to 53. Suppose you only want to save this first Windows information, then you can use this file export specific packet. You can export as plain text. No, it's not this. It's not export, it's a save as. Oh, I'm sorry. Let me see what's the export as plain text. I'm not sure why it's called K12. So let's just say this is let me see what this export is. Okay. This is export a lot of data. Let me do another way. Maybe the newer version have changed that. Let me use another one, save as. Whoa. Okay, I may not find the answer because it seems it's changed from the older version. PDU to no. Oh, this menu is not export specific packet. Export packet dissections as plain text as CSV file. So suppose you want to export a CSV file so that you can import into Excel and draw some figure. You export a CSV file, then all the packet here, and let's use this in class even as text. You can see this. This is export text because I'm using this. The MacBook has this number program. It's similar to Excel, so it can open it. You can see whatever show up here is whatever show up in the first window. So the first window's information will be saved as the pure text. Then later on, you can use Excel. For example, you use Microsoft Excel. You can process this data and draw the figure you want. So this is the export packet dissections using that menu. Okay. So Wireshark, as I said, it not only provides this graphic user interface, it also provides many packet analysis tools and modules. So from now on, I will introduce some analysis modules that included in Wireshark. So first is this, they mainly put in this tool menu, analyze and statistics. So that is the tool menu that have all the analysis modules. First is the protocol hierarchy. Protocol hierarchy basically showed all the captured packet. So let me first clean up this display filter to show all the packet, 187,000 packet. You go to statistics and protocol hierarchy. Then it will show in the entire capture trace how the packet are classified. So they all belong to the frame, so 100% frame. They all belong to Ethernet because I'm using Wi-Fi. Everything is treated as Ethernet. And then it has two categories, IP version 6, IP version 4. So even though we are using IP version 4, but all the computers, hardware, software, they are IP version 6 ready. So there are actually some IP version 6 packet generated by your computer, by some networking device. So here, IP version 6 has 4 packets. IP version 4 has 187,000 packet. And here, there are some packets that don't belong to IP version, do not belong to IP, like this address resolution protocol. This is a protocol where for data link layer, how they find each computers within the same local area network. So there are 12 packets belong to this address resolution protocol ARP packet. So ARP packet does not have this 5-layer structure because it doesn't belong to the TCP/IP protocol part. And if you want to see further classification, you open it, you can see UDP, user datagram protocol, is 55%. These are how many packets belong to this. TCP, transmission control protocol, has 44% of the packet. This is a packet number. This is a bytes, how many bytes in this packet. ICMP, remember I did a trace route. Trace route generate a ICMP packet. So there are some ICMP packet going on here, 39. So remember ICMP does not use transport layer. So it doesn't use UDP, it doesn't use the TCP. It doesn't use any protocol higher than network layer. So ICMP is directly based on network layer. So it is in the same level as the transport layer protocols. So it was defined in this way. Then in UDP, you can see these are different type of UDP, like a DNS, domain name system. There are 300 packets belong to domain name system traffic, belong to DNS. The other belong to other category of the UDP. Data. This is basically this Zoom encrypted multimedia data because all the Zoom data, they are encrypted, even though they are using UDP, it's all encrypted. So Wireshark just treat all of them as data because they are all encrypted. So you can see that the data has a lot of bytes. The majority of traffic in UDP belong to this Zoom data part. And TCP, you can see SSH, because I did SSH connection, so there are 49 packet. HTTP, 58 packet. And it showed HTTPS is 9,000 packet because majority web traffic, they are using HTTPS for this data encryption. So majority of the web traffic, they use HTTPS protocol. It's all encrypted. That's why there are 9,000 packet belong to here. Only 56 packet using HTTP. That is when I connect to the digital forensic master program website using HTTP protocol. So that's how many packet there. So you can see this, this is called protocol hierarchy. It gives you an overall picture of what kind of traffic is included in the captured trace. So that's a very big overview and very easy for you to see whether there are some abnormal traffic in here or not. Another very useful function, analysis function, is called follow TCP stream. Follow TCP stream because majority of traffic, if we ignore those UDP things, majority of data communication is based on TCP. So in one TCP connection, you could have a lot of packets transmitted going on for one TCP connection. Because when you connect to a web server, you set up TCP connection. That TCP connection can last for many minutes. So it can transmit a lot of packets in one TCP connection. Follow TCP stream is basically you can click one TCP packet, then right click and follow TCP stream. Then it will display all the packet belonging to that TCP connection. So suppose I use TCP dot port. Suppose I want to show that web traffic because web traffic is plain text. I can click any one of these packet, then right click and follow TCP stream. Then it will pop up window. This window show what data has been transmitted in that entire TCP connection lifetime. This show the HTTP GET command. This is where I connected to the digital forensic master program website using HTTP protocol. So basically is when I did this HTTP MSDF user video. Oh, this connection is called not secure because it's using HTTP protocol. So everything is transmitted in plain text. That's why browser give you a warning. This is not secure. So when I open this web page, my browser actually send this HTTP GET command. Get the root folder. So get the root folder because it's equivalent to this root folder. So the root folder will have a base HTML file and also many pictures. So this web page contain the basic text HTML file, then contain many image in it. So in this communication, in this connection, you can see that get the object, then next get, then next get. This is get to get a CSS script because the website running that script. This get is get another JavaScript, and this is get image, get the US news image, because the website has this has this picture for all the pictures. The browser will try to get that picture from the website. So you can see this picture. Then and the red font show the traffic coming from the client to the server. The blue font show the traffic coming from the server to the client. So that's the two directions. And this is get another picture. You can see this is get another picture. And so that's all the connection here. But remember this web page contain many pictures. That connection, that TCP connection, only have two picture in that TCP connection. This is because the web browser, when it set up a connection to a web server, it actually will generate multiple TCP connection to the web server. Those multiple TCP connection, each one will get a certain object from the web server. So for the original TCP connection, it only obtained two image, this image and another image. All the other image is obtained by the other TCP connections from my computer to the CS web server. If you want to, so here and you can display only one direction. So this is one direction traffic. You can see it's only blue. If you display the other direction of traffic, this is only red. And once you do the follow TCP stream, it's equivalent to you to type this display filter TCP.stream equal to 47 because Wireshark, when Wireshark capture traffic, it will automatically label each TCP connection with a number, with a unique number. So this is number 47 TCP connection. So that is how this is displayed. So there are multiple TCP connection here going on. If I only show this DST port, destination port equal to 80, you can see that this port, this is a source port, client source port. This is another client source port, and this is another client source port. So you can see that there are multiple source port from my computer to the CS web server, because my computer, the browser, set up multiple TCP connections to that web server. So from the source port, you can see how many client, how many TCP connection has been set up from my browser to the web server. Okay, any question here for this part, follow TCP stream? Um, okay, so this red colored is from client to the server. Blue is from the server to your computer. For HTTP, we can see the content because it's all plain text. But for HTTPS traffic, we will not be able to see that. So if you use 443, this TLS, and you use a click one packet and right click and follow TCP stream, then everything will be encrypted. You will not be able to see the content for the data anymore. Everything, both direction traffic, they are encrypted. And from this TCP stream, you can see that this is a TCP SYN ACK. So these are the three-way handshake for TCP connection. This is a typical three-way handshake for TCP connection. After that, it begins to transmit data. And you can see this is a client say hello, because this is a HTTPS protocol. So after set up TCP connection, the browser will basically try to get the server's digital certificate, because this is HTTPS protocol. So the browser will send a client hello message, and this is server is a hello, and also specify what kind of cipher is going to use. This is the client server. They exchange information to determine what kind of cipher do we want to use, what kind of cipher algorithm do we want to use for our symmetric key encryption, for our public key verification. This is a server hello message back. And after that, everything is encrypted, so we cannot see anything. It's just say application data. This is a 1300 bytes, so everything is encrypted. We will not be able to see the content anymore. So using this way, you can actually filter out or filter in a single TCP stream. So if you only care about one TCP connection, you can filter that and save it as a separate file. If you don't care about a TCP connection, you can use a NOT to filter out that TCP connection, then save the remaining packet into a trace file. So that's what I mean, filter out. So you can delete one TCP connections, all the packet, and save the result into a separate trace file. So then the second trace file will not have that specific TCP connection anymore. Another analysis module is called expert information. Expert information will basically give you some guideline, some expert opinion on the captured data. Basically tell you in this captured trace file, what is abnormal, what thing you should pay attention to. So that's called expert information. Let me demonstrate that. So let me clean up this display filter. It is in analyze this expert information. Expert information will basically tell you something that you need to pay attention to this trace. This red means that these are error or either error or attack that you should pay special attention to. Like this is error is invalid key length. So for SSH protocol, the key length is invalid. So it may be a serious problem that you should pay attention to. So if you open it, it will tell you in which packet it's about that. SSH protocol uses Diffie-Hellman key exchange to exchange public key data, public key information with each other. So these two packets has that problem. So when you click one, you can see the background, it had been already gone up. And yellow shows warning, just means that this packet may be abnormal, so you should pay attention to them. Maybe they are not attacked, but they indicate some abnormal thing in the network. This is a DNS response missing. It just means that you send the query, but you didn't get any DNS response from the server. So these are several queries that don't have the corresponding DNS response coming back from the server. And this is a connection reset. Connection reset, normally for a normal program, you should terminate your program by using this FINAC, that way to terminate a TCP program. But of course, some applications, they may use reset packet to terminate the connection very quickly. But normal program don't do that. So if you see this reset packet, maybe it indicates some attacker doing this connection termination. Because if attacker want to do denial of service attack, they can generate a lot of reset packet such that they can disable your ongoing connection by sending reset to the server. So these are the packet with the reset bit set as 1. So this is warning. This blue is even less serious problem, like this one, duplicate ACK. Duplicate ACK just means that the Wireshark have seen this acknowledgement packet twice in the network. It's because one computer have sent an ACK, but after timeout, it doesn't get any response from other end. Then it will send that acknowledgement packet again. So in this way, it will generate 2 duplicate single acknowledgement packet on the network. So duplicate ACK just show the these usually indicate that there's something wrong with the network. The network may be congested, so some packet may be lost. Some packet may take too long time to arrive at the destination. So the destination is timeout. So this is some networking condition indications, duplicate ACK. So these are the expert knowledge. Expert knowledge basically is expert opinion on what is going on in this capture trace. So that's the expert knowledge, expert information. Like normally, if you don't use traceroute, normally you should not see packets that have time to leave value only equal to 1 or 2, because those packets will be dropped by the network very soon. So normally you should not see such kind of small TTL value packet unless someone is doing traceroute operation. Conversation is in statistic. Conversation basically tell you the pair between the TCP conversation basically tell you what how many TCP connection is going on in the network. Suppose let's come back to the original one. Suppose I said that I'm interested in the HTTP traffic, and this is because my computer connect to the MSDF website, but I know that my browser have generated multiple TCP connection to the web server. Then I want to know how many TCP connection has generated by my browser to the web server. How do I do that? I can use this TCP.dst port equal to 80 to only show packet from the client to the web server. Then I use this statistic conversation to only show the data in this displayed part. You can see this IP version 4. There are two conversation limit to display filter. Okay, so if you click this TCP, you can see that this is a source IP address, which is my laptop IP address. This is destination IP address, which is CS web server, because our MSDF website is in the CS web server. This is a destination port, because display filter, I already specify I only display this TCP traffic that has the destination port 80. Then you can see the source port. So from here, you can see that my computer, my browser actually generated 1, 2, 3, 4, 5, 6 TCP connection to the CS web server for that web page connection. So you can see that normally a web browser should generate only one TCP connection, but because if a browser generates multiple TCP connection concurrently, it can speed up the transmission speed. So all the browsers, they are doing in the same way. They will generate multiple TCP connection to a web server in order to transmit all the objects concurrently to use this network bandwidth more efficiently. So now we can see that there are 6 concurrent TCP connection going on between my browser to the remote web server. So this is this conversation. So you can use this conversation to see this IP tab just show conversations between IP address. So it doesn't doesn't distinguish port number. So there are 2 conversation going on in terms of IP address. In TCP, there are these many of packet going on. I'm not sure why this one show up. This one is the source port is 80. Okay. And you can use the copy button to copy the text to save it to an Excel spreadsheet. Then you can use Excel to analyze it. Like conversation like TCP, you can save it. Let me see. Well, left one. Oh, yes, copy. You can copy as a CSV file. And then this table will be copied as CSV files. Then you can import in Excel spreadsheet. Then you process it using Excel functions. Statistics endpoint. This showed endpoint list. Endpoint only show the destination IP address, destination port. So each couple of that destination IP address and port will be treated as one entry in this end list. So you can see this destination IP address, it has 3 ports, so it will be treated in 3 lines. So every line will show for this tuple value, how many packets go to this destination address, go to this destination port, and how many bytes, and what's the transmitted packet, what's the received packet. So that's the endpoint. It shows the connection in a slightly different way from this conversation. So they are similar, but they are slightly different. It only shows the endpoint. It doesn't show the source. The TX means transmit, RX means received. So you can find endpoint. Flow graph in a statistic flow graph will give a graph display of the packet going on between IP address and another IP address. This is time. This is between source IP address and destination IP address. So it will give you a graphic representation. But I find this is not that useful because it can only display a small amount of packet. If you have too many packet, then this IP address entry will be so many there, and you will not be able to see their. It's just too crowded. If you only have 4 or 5 IP address, then flow graph will be useful to visually see these interconnections. Another useful one is export. This export will basically can export any object that can be understood by Wireshark. Basically, all the unencrypted traffic. If Wireshark understand that protocol, then Wireshark can assemble those packets together and generate that object. So let me give a demonstration. Export. Let me clear this display filter. This export object, you can see that these are objects that can be exported by Wireshark because they all transmitted in plain text. HTTPS object, the web object transmitted through HTTPS cannot be exported in this way because they are fully encrypted. So Wireshark is not able to assemble them together. But for HTTP traffic, for FTP traffic, this is the SMB, the file sharing. It's also original protocol is also running in plaintext. Wireshark can combine multiple packets together to assemble that like image file or JavaScript file together. Then it can export those image or JavaScript object down and save them in the hard drive. For example, export object HTTP, then these are all the objects that can be exported. It's all the connection to MSDF because in my demonstration, I only connect to this website using HTTP. All the other web connections, they are HTTPS. So for this HTTP connection, you can see this object. It's a picture. It's a lot of picture. So and also like a JavaScript because the website running JavaScript. Suppose I want to download a picture. So this is the main logo of .png. So this picture is 55 kilobytes. Remember, each packet in the network, they all under 1500 bytes, because 1500 bytes is the maximum size of all the TCP/IP packet allowed on the Ethernet on the Wi-Fi. So each packet only 1.5 kilobytes. So this is generated by assembly 20, 30 packet together by the Wireshark. So if you want to save this, you can save this file. Suppose I save it. Save it to download. Then you can see this image. So this is one image from the MSDF website, and you can see all the image can be saved because the transmission is plain text. So Wireshark is able to assemble all the object together, and you can save all the object down. So that's why when you connect to a website, using plain text is very dangerous, because all your content can be reconstructed by one attacker who eavesdrop on your traffic. So export HTTP object. Another statistic is called HTTP load distribution. Load distribution just showed for HTTP for each website, how many packets going on that website. Let me see if it has HTTPS load distribution or not. Because right now, not many websites allow HTTP connection anymore. All the web traffic, they all belong to HTTPS. So let me see. So what's the menu? Statistic, HTTP. It only has HTTP packet counter request. It doesn't have HTTPS, because HTTPS you cannot analyze that much. So it doesn't have that function for HTTPS traffic. But it has a DNS traffic. So let me see, DNS query response. So total query is 158, response is 158. And these are the classification of all the DNS traffic. It's all about HTTP analysis, but I don't want to introduce HTTP analysis that much, because it's not that useful anymore. No one uses HTTP for web connection. So Wireshark, to improve Wireshark performance, first is don't use capture filter. So this is a little bit contradictory. You use capture filter because you want to limit how many data I want to save to the hard drive. So if I only want to save a TCP packet, then in the display filter, I use TCP there. So this will save my hard drive. However, it will slow down your computer speed. This is because if you capture everything, then all the packet will be saved to the hard drive. Your Wireshark does not need to check every packet. But if you used anything in the display filter, then for every eavesdropped packet, Wireshark will first check whether this packet satisfies that display filter, satisfies that capture filter rule. If it satisfies that capture filter rule, then it will be saved. If it does not satisfy the rule, then it will be dropped. So you can see that with the capture filter, your Wireshark need to do additional job for every packet. So that's why to improve performance, you should not use capture filter. Increase the read buffer size. Of course, if you have bigger buffer, you can have bigger. Don't update the screen dynamically. Normally, when you open Wireshark, the screen will keep flashing because you have more data going on. It will keep flashing. So that the flashing of the computer screen is also taking this computer resource. So you should minimize the Wireshark when you actually capture data so that it doesn't need to refresh the computer screen every time when you have a packet. Or get a faster computer, of course. Use a tap. Tap just means that this physical device that can mirror a link, like if you have an Ethernet link. Instead of put the Ethernet link to your Wireshark capture computer, then another link going out, you install this tap device. This tap device is that for one input, it has two physical output. The two physical output will have identical traffic. So in this way, you only put Wireshark monitored computer on the second output of the tap device. You do not interfere with original traffic transmission. So if your Wireshark cannot catch up with this big traffic surge, the traffic can go through. Your Wireshark can only capture maybe 50%, 60% of traffic, but you do not slow down your network. So normally when people use Wireshark to capture network traffic, they don't install Wireshark on the firewall or on the gateway, because that will slow down the router, slow down the firewall, and slow down the entire network. They install it on a dedicated computer. This computer connected to the physical link using a tap device. So you do not interfere with original network operation. So that's the tap. Don't resolve name. By default, Wireshark does not resolve name. Here you can see all the source and destination, their IP address. But in the capturing, you can actually specify that I want to resolve the name. Then for every IP address, for every packet going on, Wireshark will try to do a reverse DNS lookup to find whether for that IP address, whether there's a domain name associated with it or not. If there's a domain name, then here it will display that domain name. So that means during the capture, Wireshark need to do a lot of DNS query. So if you capture 10,000 packet, your Wireshark may have done like a 1,000, 2,000 DNS query. Try to find the domain name for each first C IP address. So that's the way that don't resolve the name. But default configuration will not resolve the name. Post-processing, you can save the data, as I showed several times, you can save the data in this CSV format, in a text format. Then you can import them into your Excel spreadsheet or other text processing program to analyze and to draw figures, because sometimes you want to draw a nice figure. So Excel spreadsheet can draw a very nice figure. So you should export data and import into Excel and process. Another way you can use some text processing way, like in Unix machine, you can use grep command. You can use grep command to do text searching. And like if you want to find how many times one IP address has appeared in the captured trace, you can simply do a grep command on the saved text file. And So that is a very easy way to see how many times this IP address has appeared in this trace file. So this is about grep. We will use grep from time to time in my in-class operation, because later on when I use Linux machine, grep is a very useful tool to do some basic text searching. And Wireshark has been widely used by everyone, from attacker, from defender, from the researcher, from this company people who really do network analysis. So there are many public available captured trace out there shared for the community. So you can process those captured trace and analyze them. Like this is a Wikipedia page for Wireshark. It has some sampled capture. Most interestingly is some security trace that you can analyze to analyze some security attack contained in that trace file. In many network cyber security competition, especially in capture the flag computation, like right now there are many capture the flag cyber security competition organized by different government agencies and college universities. They are mainly for college students. And one big competition format is called capture the flag. Capture flag just means for all the teams, I give you the same vulnerable machine, and I ask you to find out what is contained in this vulnerable machine. What is like a password? What is a secret file name in this machine? And network trace, this network trace is another way to give to all the participants. Ask you to analyze this network trace to find out what is going on in this network trace. Can you find a specific attack from this network trace? And here are some network puzzles, network forensic puzzles out there. Let me see. Like this one, forensic context. These are some online network cybersecurity challenge. They provide a trace, and they ask you to find out, then analyze the trace and find answer to some trace. This is another cybersecurity challenge. And this is the trace file. You can download the trace file. This is a question sheet. So basically, when the competition start, every participant will give this capture trace, then ask you to answer those questions within like a 4 hour, 5 hour. Who can answer those questions most accurate, and they will win this contest. So this is one good example, packet challenge, a good example. You can download the trace and see what is this question to answer. Basically, find out server's IP address, host name of that server. Of course, this is a very simple one. As a question going on, it will become harder and harder to give the answer. And you can capture your own traffic trace, as I demonstrated in the beginning of the class. When you start capturing of your computer, you can do DNS lookup, manually do DNS lookup, do ping. I didn't do ping. I used traceroute. I didn't try ping. Traceroute, browse some website using both HTTP and HTTPS. You can do SSH connection to SSH server. Then analyze the capture trace file to see what packets are out there. For example, I did a trace route. So how can I find out those trace route packets? traceroute using ICMP, Internet Control Message Protocol. So I can simply first search ICMP to see those packets. Those protocols all belong to traceroute. So these packets, remember traceroute is basically send the packet to the destination where it has a very short time to leave value. And this time to leave exceed is ICMP packet generated by the router when it drop a packet, it send a ICMP packet back to the sending machine. So this is my sending machine. This is .99 is my computer's IP address. Traceroute is actually okay. Let me show IP.ttl equal to 1. Remember, the first bunch of packets sent by traceroute has TTL value equal to 1. So you can see this is this is 1, this is 1, this is 1. So this is 3 UDP packet. So traceroute will actually send UDP packet. But when the router drop a packet, the router will send back ICMP packet to tell the sender that your TTL value expired. So ICMP packet is not sent by the traceroute sender. It's sent by those router who dropped those packet. So the traceroute will actually send a UDP packet to the destination. This is remember when I tried the traceroute, I tried to Google traceroute google.com. So this IP address is google.com IP address. This is my computer's IP address, 10 something. So traceroute will send 3 packets with TTL value equal to 1, then send 3 packets with TTL value equal to 2. So TTL value equal to 1 is this one, and this one. And this time to exceed is the response packet by the router come back. As IP TTL equal to 1. Let me see this one. TTL value is equal to 255. It's not 1. Why this packet show up? This one I know, this is a traceroute sending packet. It has time to leave equal to 1. But this is the response packet is from the first hop to my computer. It actually, TTL value is not equal to 1. Maybe treat 255 as 1 as well. Let me see, TTL value equal to 2. You can see this is traceroute sending out this 3 packet to the second hop. It's a TTL value equal to 2. But the response packet doesn't have. I believe this one shows so many one because this ICMP packet returned by the router, they have TTL value equal to 255. So 255 was treated as equal to 1. Let me see. I'm a little bit confused here. So I don't know why this packet will show up because their TTL value is certainly not equal to 1. But so basically from here we can see that from TTL value equal to 1, we can see that the first hop is 112. It will respond. And TTL value equal to 2, I can only see the sending packet. I do not see the response packet. PPL equal to 3. You can see for every TTL value, 1, 2, 3, 4, it's always a 3 packet sending out. But if I want to see the response packet, I can just see SCMP packet. And based on, so you can see this is 3 packet, all from the same source IP address. So this 112.1 must be the first hop in this traceroute path. This 67.4 should be the second hop in this traceroute path. So from here, we can figure out this traceroute path, what is IP address in this traceroute path. This is a third hop. This is a fourth hop. But as time goes on, the order may be slightly obscured. Like this only showed us 2. It didn't show the third one. The third one may be missed, maybe dropped. So it only showed. And this one, I'm not sure why this one come up, but this is 3 times. This is the 3 times. 201 is 3 times. 153 is 3 times. So clearly, it's a very regular. Every 3 packet will come up. But out of order, some packet will have time to live. This may not be cause trace loss. This may be because the normal ICMP packet on the network. Okay. So you analyze the packet and see for yourself. DNS lookup, I did a DNS query by myself, but the computer did a lot of DNS by itself. So there are a lot of DNS packets here. There are 300 DNS packets. But in my query, I did a UFL.edu. Remember, I did in my operation, I did this dig command, query for www.ufl.edu. If I want to see this packet in the capture trace, what do? I can use DNS contains UFL. So I will see which DNS packet that contains this UFL keyword in it. Hmm? Oh shoot. It doesn't have this because in DNS query, even though it's not encrypted, but it doesn't have that domain name in ASCII string. Like UFL, it doesn't saved as each character as ASCII string. So you cannot see like if I only show DNS query, yeah, it's too many. How do I find the UFL one? DNS, let me see, DNS, I want to see what a substring DNS has. Certificate, CNAME. DNS oh, I haven't used this one before. Standard query. What show up here is what interpreted by the Wireshark, but this text, this domain name doesn't save in this content as ASCII text. So we cannot find UFL. Let's see. It has, but edu has one, UFL. Yeah, it doesn't have MSDF as well. Why it has this edu one? Let me see if I can find Eustace, EUSTIS. Yeah, it has this one. So standard query Eustace, standard query response Eustace. So it is saved as ASCII string, but why I cannot find UFL? Did I type something wrong there? Hmm. Let me restart capturing. Do a dig command again. Dig like okay. Then stop line C DNS contains MIT. Whether I can find it or not. Um, okay, I think the reason is because my Mac OS, it always query to this opendns.com. It OPT, it doesn't do this, it doesn't query to the local DNS server. I'm not sure why my Mac computer doing that. It only queries standard queries sent to this OpenDNS. It doesn't send the local DNS server, so it doesn't put that text in ASCII text string format. On your own computer, if you do DNS, like on Windows computer, you can use NS lookup instead of dig command in Mac computer. In Windows computer, when you open a terminal, you can use NS lookup and domain name to do a DNS query. then you should be able to use DNS contents that ASCII string to find the word query corresponding to that domain name query and corresponding response. Okay, that's all for this